will start our class. Good afternoon, everyone. First of all, chapter 4, climate geography. So we were discussing about the 6 major controls of climate. 6 major controls of climate. So in this we had, first we have latitude, then altitude, then we have pressure and wind system, pressure and wind system, then you have distance from sea, ocean currents, and then relief features. So these are the 6 major controls of climate. Now first one we were studying yesterday. So in that, if we see the latitudes, this is the 0 degree equator, which actually divides the earth into 2 hemispheres, 2 equal parts. And this is northern hemisphere, this is southern hemisphere. Here you will have the north pole, here you will have the south pole. After that you have some of the major latitudes, main latitudes. Then here you have Tropic of Cancer, here you have Tropic of Capricorn, then you have Arctic Circle, then you have Antarctic Circle. Now these latitudes are actually divided, they actually divide the earth into different climate zones. Now these climate zones are, see this equator, near the equator, this is the hottest place on the earth. The equator is the hottest place on the earth. Now this area from Tropic of Cancer to Tropic of Capricorn, this area actually is called torrid zone. You would have read about this in your previous classes. So this is torrid zone, and here you will find the climate which is actually hot. Hot type of climate will be found in this area. Now we go to this area, and this area is basically called the temperate zone. And the climate which you will find is kind of moderate climate. Moderate is average climate, not very high, not very hot, not very cold. Moderate type of climate. Now this area near the North Pole, this area is the frigid zone, and this zone is the coldest place on the earth. These areas are the coldest place on the earth. So this is what we exactly understood in our previous class. But how is this? Why is this? Can anyone answer me why the equator is having the hottest climate? Also, one more thing I want to add, because I have the newcomers, no? Every time I have some newcomers here. I feel they have debuted. They are debuted in the class. Like you have debut heroes, the same way I have debut students. After some time, they just appear from somewhere, and again they just go to some different planet. This is what I feel. So latitude is basically imaginary lines. Imaginary lines, they are the horizontal lines. They are horizontal lines on the earth. Horizontal means like this. Vertical is like this. So vertical lines are basically longitude. So here we are only discussing because latitude affects on the climate. Longitudes do not have any control on the climate. That also we will discuss. Now the latitudes are the horizontal lines made on Earth. They are imaginary lines. Imaginary means calculated. They are not actually on the Earth, but they are made on the Earth by us, and we have made this so that we can exactly locate the places. For that purpose, we have made some imaginary lines. So in that, the horizontal lines are the latitude. Now, yesterday I was saying that keep the globe in front of your face. That means the height of the globe, the height on which you keep the globe, and your face should be on same height when you will see the globe. Because our Earth, how is our Earth? Our Earth is tilted. It is not straight. It is tilted like this. So this is north and this is sun. It is kind of tilted. Now here you will find the equator. Now here is the sun. Sun is not tilted. Only Earth is tilted. Okay. So here you have the sun. So when sun rays come, this area is having a brighter sun ray, broad sun rays. This area, the equator is facing the broad sun rays. Okay. Braj is saying something, as the sunlights fall directly on the equator, so the air becomes warm and become capable of capturing more moisture, which makes it modern. Okay, correct. That is a correct answer. So here we will understand this is sun and it is directly putting the sun rays here. Okay. So this area is becoming more warmer, right? But when the sunlight will go till here, you will find here it is going in a slanting way. So here, when it goes to the poles, when it comes here, it will not reach here, if you see. Understood? Because our Earth is tilted. So at this time, here it will not reach. It will not reach to South Pole. If it is reaching to North Pole, it will not reach to South Pole. Understood? It is giving the sun ray, straight sun rays will be there on the equator, but slanting rays will be there on pole. Now, if you have read in previous class, you will find that at that time only one of the pole receives the sun rays, and this pole will receive the sun ray for 6 months. This will receive for 6 months. After this, as you know, this is rotating. Okay, this one is rotating on the axis. This is the axis. Okay, so it is rotating on the axis as well as it is rotating around the sun. Yes. So when this Earth will rotate, this is called revolution. This is revolution, and when it is moving on axis, it is rotation. So when it is revoluting, it will come here like this, then the scene will change. Now the South Pole will receive the sunlight, but the North Pole will not receive the sunlight. Right? So this is the basically scenario. And in this, if you see, the North Pole or South Pole, they are getting the sunlight continuously for 6 months, and for continuously 6 months they are dark. They are not getting any sunlight. So anyways, those places will be the coldest place, right? The sunlight which they get in this 6 months, that is also the slanting rays are coming. So for this we can see, we can observe the thing like this. When it is afternoon, the sun is just above us. Okay. When it is afternoon, the sun is just above us. You know the sun, actually our earth is moving, but when we are on earth, we imagine the different phases of sun. Okay. So like this, in morning if you see, this is east. So sun is here. Sun is here from it, here it is raising from east side. So when sun is here, you won't be getting any sunlight. When it is here, you will get the slanting rays. So in morning when we get the slanting rays, we don't feel that much warm. But when it comes on our head, which is at afternoon, the sun just exactly comes on our head. So we feel hot that time. Again, the sun goes here by evening. So in evening also you are getting slanting rays. So at that time also you will feel less warm if you compare to afternoon. So this you can feel, you can observe in your daily life also. That the sun's position, the position of the sun, the rays in which direction we are getting the rays, that is the factor for increasing the temperature and for decreasing the temperature. That means the relation of the temperature. Understood? So if slanting rays comes, the temperature will decrease, and when straight rays comes, it will increase. Right? So same happens with the earth. When the areas which are getting the straight sunlight will be hotter. So equator is the area which is getting the straight sunlight. And the poles, they are getting slanting sun rays. And that also if you see, one pole is getting sun rays for continuously 6 months and one pole is in dark for 6 months. So like this if you see, the latitudes, and this is because of the curvature of the earth. This is because of this curvature of the earth. If you see this area, this is a curve. Right? So this same I was explaining yesterday, that if you place the globe in front of your face, you will find the middle area which is equator, you can see that area properly. But when you try to see the North Pole from the same direction, from standing at the same place, you will find that you won't be able to see the North Pole. To see the North Pole, you have to go above the globe. Right? So you can see, do this by observing the globe also, how the sun rays are going on that. So you can see that you will able to observe able to see the equator properly, but North Pole and South Pole will not be visible. The same way, for the sunlight also same happens. The equator gets the direct sun rays and the poles get the slanting rays. Okay, and so like this if you see, the temperature on the equators are high. The temperature on the equators are high. But as we go towards poles, when we move towards poles, we will find the temperature is low. Okay. The temperature is high at equator, but the temperature is low when we move towards poles. Okay. So any question in this? Anyone? Anyone is having any question in this? This is only we need to understand in latitude. Okay. So if you see, equator is the hottest place and the places which is near to equator are having a hot climate. Okay. And when near to the North Pole or near to the South Pole and far from the equator, these areas will have the low temperature. Okay, the temperature decreases when we move towards poles. This you have to understand. Okay, no questions. So I just want to end the Zoom session here only, and in next class we will discuss the next control of climates, and tomorrow you won't be having the history and science class, that I want to tell you. On Friday we will again have the class and we'll discuss the further topic, and Zoom session will be end here only, it will end here, and we will continue on WhatsApp. Okay, thank you all.